Method number 2. To find the true length of a line, we are using the triangulation method. First, I will use the same dimensions as before to construct the true length of a line. Okay, so I'm going to use the same dimensions. First, x and y. $10mm. A distance of 45. The front elevation I used 60. So I set my compass to 60mm. And the plan, I'll use 55 again. I use here a 5mm guideline. As you see, I'm not pressing too much on the pencil to give me that effect of construction line. I'm simply just drawing lines at the moment. Oops, I forgot this one. I might not use all of it, but then it's important that we draw accordingly, you know? So this is front. And that this is plan. Right? Label. This is A. This point is A. Top is B. The bottom here is B1. A1. This is X. This is Y. Okay. And the plan front elevation. For this method, which is triangulation method, I want to extend the, I will obtain one for the front. If I use the front, it means that I am obtaining the true length of that AB. Okay, if I project at AB1, I am obtaining the true length and the angle of inclination to A1B1. So this time I simply extend and I I will extend B as well across. I will establish a vertical line somewhere around where it does not interfere with this. A vertical, right? So what do I do now? I need to get this distance. I set my compass to A1, B1. Do not be estimating. You need to get the correct dimension. Okay, A1, B1. Okay, using this dimension. But before I do that, let me label this line here. I just extend my lines as I've already projected, so let me extend my lines here. And this one as well. Just to get a better indication or idea. So this point is K. This point here below is L. Okay? So we have line K, L. So having set your compass at A1, B1, which is the plan, okay, A1, B1, I want to set at L. L is this point here. And I want to scribe an arc onto this horizontal. Okay? This point is M. And to obtain the true length of line AB is joining K to M. Okay, so this is the true length of AB, and this is the angle of inclination for AB. I will just use this to get a smooth arc. Okay, so this is the angle of inclination, and you can measure it so that you can write the information next to it. Okay, let's do that. So the true length, let's measure the true length. .67. So we're going to write TL, true length, equal 67, and we want to measure now the angle of inclination. Is 35. I have here. Let's see. .35. So here, this is the symbol that we will use. Angle equal 35 degrees. Okay, so every time I use this method, this is what I want to see. TL standing for true length, which is 67, and angle is 35. This angle means angle of inclination. Okay, angle of inclination to the horizontal plane. So angle 35, and then we're going to write HP, or horizontal plane. Okay, that's the front. Now for the plan, is the same concept. So I will project I will use the same KL I want to label again. As I mentioned, don't worry about the lines. Once you stay focused, you cannot go wrong. Okay, so we know here that this is K again, this is N, and we need to find M. To obtain M for this, given that I'm projecting here, then I use this dimension. When I project it here, I use the A1 B prime. But now that I am projecting here, I need to use the opposite, which is AB. So I need to set my compass to AB. And this is what I use. And I set an L. And I project here on this space. So this point is what I know as M. So I want to join M with K. And once again 5 mm for these points. Right. Let me use this tool. Just to get an arc. Right. So let's take a look at the distance. 67. So TL again, true length. And the angle of inclination for this line is 25 times 20, 25, 27. So we say angle equal 27 degrees, but this time it's the vertical plane. Okay, so this method is called triangulation method to obtain the true length of a line and angle of inclination. Okay, so that is the second method. Thank you very much for following, guys.